To convert from standard form to vertex form, we perform an operation called completing the square. Completing the square tells us to look at the coefficient on the x term, take half of it, and square it. So in this case, we take half of 4, which is 2, and square it, which gives us 4. So we're going to add 4 into our expression. And then we have the 10 that we already had. But since we added 4 into our expression, we need to subtract 4 to balance that. Now we factor the first 3 terms. When we factor x squared plus 4x plus 4, it will necessarily factor as a perfect square. That is the whole idea behind completing the square, giving us x plus 2 squared. Right? If you multiply back out x plus 2 squared, you'll get x squared plus 4x plus 4. Then we have this matter of the constants from the previous step. 10 minus 4 is 6. If we want to convert from standard form to vertex form, and our a is not equal to 1, we first have to factor that out from the first 2 terms, making this 2 times x squared minus 2x minus 1. Notice we didn't factor the 2 out of the minus 1. Now we continue with the process of completing the square. So we look at the coefficient on the x term, which is 2. Divide that in 2 to get 1, and then square it to get 1. So we add that inside the parentheses. So we get 2x squared minus 2x plus 1. And then we have the minus 1 that we had from the previous step. But we have to balance our expression because we added 1 inside the parentheses. Now notice that since we added 1 inside the parentheses, everything in those parentheses is being multiplied by 2. So we really added a 2 to this expression. So to balance that, we have to subtract 2. Now we factor what's inside the parentheses, giving us 2 times x minus 1 squared. Right, if we multiply out the x minus 1 squared, we'll get what's in this parentheses again. And then we have minus 1 minus 2 just becomes minus 3.